All right. Hello, everybody. Welcome to day 146. Today we had a Zoom meeting. If you weren't able to attend, here is the makeup Zoom.
Daddy, I need help picking up one of my peanut unicorns.
You do?
It's too slippy.
It's too slippy?
Mm-hmm.
I got it. Unicorn. Luna, go get your Hatchimal. Luna, baby. Sorry. Your Hatchimal's over there by the Coke can. Right over there. Go get your Hatchimal.
Okay.
All right. Cool.
Where?
By the Coke can. This is how you survive the quarantine. You freeze all their toys in a big block of ice and make them get it out, like that guy over there. Oh, stepping in it? Okay. Oh, pants are wet. Great. All right, day 146. We're looking at wave interactions. And so for this lecture, we're going to go through the warm-up. Oh, good job. Go through the warm-up, and then we're going to look at two waves. Look at a wave generator. And see how waves interact with each other. Or if you have two waves and they collide, what happens? So if you haven't done the warm-up yet, please go ahead and do so now. And welcome back. So if two waves collide with each other, does anything happen? Well, yes. If you have two wave peaks or crests, sometimes they're called, and they collide with each other, they're going to make a bigger wave. You've probably seen this somewhere, two boats going next to each other, and their waves come together, and it makes this big sploosh, right? Or you're in the bathtub, and you make some waves. Luna, put your pants back on. No, you're fine. No, you're not going to sit in there. Jackson, stop throwing her toys. Quarantine, fun. Okay, so yes, there would be a result, and then more specifically, if the peak of a wave collides with another peak. So here's two peaks. Imagine each of these has a value of, say, 5. 5 and 5 comes together to make 10, right? Now imagine you had a peak and a trough, and they come together. This is positive 5. This, negative 5. What's positive 5 plus negative 5? 0. All right, you'd get a smaller wave or no wave at all, and that's what we're going to see in the video. So, for our little discussion today, we first looking at what's caused in the water by the up and down movement of the tennis balls. So let's take a look at that by watching this video, which is probably going to load. I don't know about you guys, but I need a haircut.
If I add a second source of ripples...
All right, so there's just a first source of ripples, right? We can see these nice waves. They're all circular. We're adding a second set.
Then we start getting an interesting pattern.
Good job. Do you see these lines that are starting to form right here? These are lines where it's fairly smooth. Look at the size of these ripples up here. And then now look at these ripples down here. Which one's bigger, Jackson? The ones up at the top or these ripples down here at the bottom? Which ones are bigger, top or bottom?
Bottom.
Bottom. Very good. That's because of constructive interference. Can you say constructive interference?
Constructive interference.
And what happens when you do construction? Do things get bigger or smaller?
Bigger.
That's right. So that's it, right? See, 5-year-old. So this is called constructive interference, and this is those two peaks coming together from his two big tennis balls, right? So two peaks coming together and adding 5 plus 5, 10. Right? And in between, we get these troughs or valleys, and those are actually negative 5 and negative 5. Jeez, it's hard to do. Negative 5 and negative 5, which gets you negative 10, right? So bigger peaks, bigger valleys, bigger crests, bigger troughs. There's lots of words for these, but bigger than what they originally were when there was just one wave generating source. And then also, we get to these places where...
For Mommy's birthday and his surprise, let's make all of her jewel rings to get inside ice.
You want to do what she did to you?
Yep.
That's called karma. All right, let's do it. Mom's birthday is in 6 days. We're going to freeze some of her jewelry. Think she's going to like that? Good thing she doesn't subscribe to my channel. Maybe she does. I don't know. Anyway, okay. So in between here, we've got these areas where we've got the peak and the trough, and they're almost canceling each other out. This is basically smooth water right here. So I asked you for the discussion, all right, what happens? Okay, so we see some bigger peaks, some bigger troughs. At 28 seconds, how many lines do you see? Let's see, let's get to 28 seconds.
This pattern is created by the ripples from the two sources interacting with each other. Where they meet up peaks with peaks and troughs with troughs, the amplitude of the wave is increased. That's what we call constructive interference.
Here,
but if the peak
here,
from one wave
here,
meets up with the trough
here.
from the other, then we get destructive interference, and
See
there's
that? He made
basically
those
no
white.
wave there.
So that's what we're supposed to see at 28 seconds, is see what's called destructive interference. When you destroy something, you make it go away.
Interference, and there's
All right, and so that's these smooth places right there. And if we go back to 23 seconds, which was my other question, then you can see where they've been built up, and that's here. This is all the constructive interference. So that was basically the essence of what I wanted you to see. How are these waves being formed? Again, like peaks are adding to peaks, troughs are adding to troughs, peaks and troughs are canceling. What's up, babe? We don't have any more cake. It's all in your tummies. Oh, posture. Okay. So that's it for the discussion and the warm-up. For class today, your job was to look at waves, specifically standing waves. So these are waves that look like they aren't moving, which is really kind of a cool phenomenon. And my coworkers are really loud. They won't be quiet. And also to look at how that applies to musical instruments. So you'll see things like standing waves like these, right? You may have even made some of these things before. If you take a string, have fixed ends on both sides, and you just vibrate one side, right, with like a little spring or a string, you can get these little wave patterns to form. Works really well with a springy, slinky thing, but also works great with a necklace or other kind of medium heaviness cord. So making these wave patterns, that's what you're going to be looking at. And a couple of videos here to learn about standing waves and how they connect with instruments like guitars and pianos and violins and other stringed instruments. And then some guided reading about wave interactions where we kind of firm up your concepts of constructive and destructive interference, standing waves, what they all mean, their official definitions. You're going to do that through some reading. And the link for the reading is here. If you can't get onto Schoology, you can access the the guided reading document here, and then you can just upload it on your own. And that's it. Tomorrow we're going to have a quiz and see how you're doing so far with all this waves stuff, and go from there. Okay, that's it. Have a good rest of your Thursday.